Okay, so let's go ahead and get started. We're going to do 2.3 here. 2.3, we're talking about simplifying variable expressions. Okay, to simplify variable expressions. So if I have an expression that looks like this, okay, if I want to simplify it, this is also known as combining like terms, So you have to find like terms here. So like terms here would be what? This is 5x and this is 4x. So these two would be like terms. They're expressed in how many x's, right? So I have 5 x's here and I have 4 x's here. So if I do, these two are the like terms. And if I combine the like terms, I have 5 and I have 4. So 5 plus 4 is going to be the total of 9 x's. Because I have 5 x's here and I have 4 x's here. Okay. Now this guy here is not a like term because it does not have the x. This is just a plain number, or sometimes called the constant term, because there is no variable to it. It's just a number. Okay? So the 7 just becomes over by itself and this becomes 7. So the simplified expression would be 9x plus 7. Okay.
Do you add 9 plus 7 at the end?
You cannot add the 9 plus 7, 9x plus 7, right? Because these are in x's, and this is just a term by itself. It's 7, right? Good question, AJ. Thank you. So it's 9x plus 7, and you cannot go any further. You cannot combine those two together, okay? Now let's say that instead of plus here, you had a negative, okay? If I had a subtraction here, what would I have? I had 5 x's. I'm subtracting 4x out of the 5x, right? So if I combine these two together, what do I get? I get only 1x left, right? So I had 5, I took away 4. So all I have left is 1x. And again, the 7 just becomes a 7. And it's x plus 7. You cannot combine these together again, because this is in x's and there are no x's in the 7. Okay, it's just a constant term. Okay, so this is what we talk about when we talk about simplifying variable expressions. Okay, so let's see if we can go and do some examples here. Example number 1. Example number 1, we have identify the terms, like terms, coefficients, and constant expressions. We have y plus 8 minus 5y minus 3. Okay, so one thing we did not talk about earlier that I should have talked about was coefficients. So the coefficient here, okay, so you have negative 5y. The coefficient here is the negative 5 portion right here. Is called the coefficient. This is called the coefficient. Okay, over here, the coefficient would be the invisible 1 that you're not seeing here, right? There's a 1 here, right? Okay, because it was just y, right? Okay, so what are the like terms here? What are the like terms here? Josh, give me what are the like terms here?
One of the like terms is, hold on.
What are the like terms?
Negative 5 and y.
Yeah, so these are the terms that have y's, right? So they are like terms, right? And then these two are also like terms because there are no y's and they're just numbers, right? So I can rearrange this as y minus 5y plus 8 minus 3, right? The associative property says that when I'm doing these, I can go ahead and rearrange them as such. So if I do this to, what do I get? I get y minus 5y. So that's going to be how many y's altogether? Delilah, can you tell me how many y's I have?
You have 2.
Huh?
You have 2.
I have 1 here, and I'm subtracting 5. How many do I have altogether?
I don't know.
Huh?
I'm not sure.
Not sure? Okay. Dino, some help here.
Sorry, I have a cat. What?
So I have a y, and I'm subtracting 5 y's from there. How many y's do I have altogether?
-5.
-4, right? -4, right? Because I have 1, and I'm subtracting the 5 away, so I'm going to end up with -4 y's, correct? I had 1, subtract 5, so it's really 1 minus 5 here to get the -4. That's where the -4 here comes from. Okay, Delilah, what if I did just the constants? What do I get?
If you what the constants?
If I do just the constants, I have 8 minus 3. What is that?
5.
5, correct? So it's going to be 5. So this is your answer, -4y plus 5. Okay, -4y plus 5. Okay. Let's do example number 2. Example number 2, simplifying an expression. I have 4n minus 7 minus n plus 9. Okay, so I have to combine the like terms here. Elijah, give me the like terms here.
Where is that at in the book? I can't read the whiteboard. It's too pixelated on my screen.
And we're on page 79, example number 2.
It's 4, 9, and or not 4. Yeah, it's 4 and 9.
4n.
Oh yeah. 4n is and
Are there anything else that contains an n?
what?
Is there anything else that contains an n?
No. Oh, there's an n that's by itself.
Yeah, -1n over here, right? I have -n, right? So these two are the same, right? Okay, which leaves the other two, which is -7 and 9. And those are, what terms are these called? Pastor.
The what?
The -7 and the 9, what are those called?
Constant?
Constants, good. So I'm going to rewrite this as 4n minus n. Then I have -7 plus 9, correct? So if I combine the 4n minus n, what am I going to get?
Sorry, what?
4n minus n, what do I get?
4n or 4, sorry.
I had 4n and I subtracted one of the n's away. How many do I have left?
Oh, 3n.
3n, good, 3n. And then I have -7 plus 9, and what is that?
-2.
Plus 2, there you go. So your answer is plus 2. So 3n plus 2 is your answer, okay? Let's do example number 3. Example number 3 is simplified with parentheses. So I have 2x minus 4 plus 9x plus 1. Okay, and this was A. Okay, So the very first thing that I'm going to have to do here is I'm going to have to get rid of the parentheses, right? I'm going to get rid of the parentheses, okay? So if I do that, I'm going to do the distributive law. 2 times x is 2x. And then I do 2 times minus 4, which is negative 8, plus 9x plus 1. And I look for common terms, like terms here. So I have the 2x and the 9x. 2x plus 9x. I'm going to have the negative 8 left over, plus the 1 here. If I combine the 2x and the 9x, I'm going to get 2 plus 9, which is 11x. Then over here, I had negative 8 plus 1, which is going to be negative 7. So that would be your answer. Okay. Let's do B. So in B, we're going to have 3K plus 2. So if I do this again, I'm going to do get rid of the parentheses first. So the 3K just comes over, and then I'm going to have negative 8 times K, which is negative 8K. And then I do this, I have negative 8 times 2, negative 16, okay? So if I go ahead and now combine the K's together, I had 3K, I subtracted away 8, so I'm gonna end up with negative 5K, and this guy just comes down as negative 16, okay? And we'll do C. In C, we have 4A minus 4A, oops. Minus 3. Okay, so again, we have parentheses here. What you're not seeing here is the 1 there, right? There's a 1 there because 1 times this is the same, right? So 4A, now I distribute the negative 1 out. I get negative 4A. Negative 1 times negative 3 is plus 3. Now if I combine these two, I get 4A minus 4A. So that becomes a 0A, which is basically 0. Because I had 4, I subtracted 4 away. So that's 0. And then over here I have plus 3. So the 3 just moves over. Okay. And last but not least, let's see if we can do a word problem. Example number 4. Example number 4, it says, during your workout describing pace every day, you spend a total of time of 45 minutes jogging and swimming. You burn 14 calories per minute when jogging and 8 calories per minute when swimming. Let J be the time you jog in minutes. Okay, write an expression in terms of J for the total calories you burned during the workout. So you jogged and swam, so jogging and swimming together is going to be 45 minutes. Okay. And it says that you jogged for J minutes, right? It says let J be the time you jogged. So if I jogged for J minutes plus the swimming time is equal to 45, which means that the swimming time is what? Is basically 45, whatever left over, right? Whatever's left over from the 45 minutes is the swimming time. So your jogging time is J, and your swimming time is going to be 45 minus J. So you're going to burn how many calories when jogging? Well, jogging, you're going to burn 14 calories. And when you're swimming, you're going to burn 8 calories. So the total calories burnt during jogging is the time you spent jogging times the 14. So it's going to be 14J. And then the calories whether you burned during swimming is going to be 8 times 45 minus J. Okay, so there right there is your expression for the total calories that you burned during your workout. B, find the total number of calories burned if you jogged for 20 minutes. So in here, what they're doing is they're telling you that, this is B, that J is 20. You jogged for 20 minutes. So all I'm gonna do is put in J here with 20 for where J is. I'm gonna get, well actually, let's work back a little bit. We were supposed to, let's go ahead and simplify this here first, okay? 14J plus 8 times 45 is 340. 8 times negative J is negative 8J. I combine the like terms here. So it's 14 minus 8, 14J minus 8J, total of 6 J's plus the 340, correct? So in B, they're telling you that J is equal to 20. So I'm just going to put 20 in here, right? 6 times 20 plus 340. 6 times 20 is 120 plus 340, 460. 480 calories. Where did I get 480? Oh, this is 360, my bad. This is 360. This is 360. So this is 360. This is 360. 360 plus 120 is 480. Okay? All right. Okay, were there any questions on what we talked about today? Any questions? No questions?